Good? Oh. Good morning. I like my audience a little bit louder. Good morning.
Morning.
Good morning. Thank you for coming. Thank you for staying until the end of the conference to the last talk possible. Appreciate it. I woke up this morning with a really bad cough and really bad sore throat, which kind of sucks. So if I cough, I do apologize. I had estimated for the cold to appear tomorrow, but as any good software developer, I suck at estimation. So this is actually my last talk for the year, and I think this year I've done over 60 talks, so it kind of sucks that it just came right before the last talk. But anyway, I'll try not to blow my nose, but yeah, we'll try. So how many of you have actually heard of Kotlin? Okay, how many of you have played with it? Right. How many of you know the features of Kotlin? Okay, so quite a few people that are relatively new to it. Right, so I'll just give you a quick summary of Kotlin. And actually, that is done. Kotlin is a language, statically typed, object-oriented language that targets the JVM, bytecode, and JavaScript. And I'll get back to the JavaScript part a little bit later. It's licensed under the Apache 2 OSS license, and its current milestone is M3 or M3.1. And we think that there's going to be an M4. Well, there will be an M4, there'll probably be an M5, and then we hit beta, hopefully. If you didn't know, just some general knowledge, Kotlin is also an island off of St. Petersburg. Kotlin is also the name of the class destroyer. It's not like JavaScript that destroys classes, but it's a class destroyer. How many of you like JavaScript? Believe that the world would be a better place without JavaScript? Good. Kotlin also means kettle in Russian. And if you didn't know, that's because JetBrains was originally, it still is, Russian company, and the majority of the people at JetBrains are Russian, except me. In German, Kotlin means shit. And lean means tribe. So you can also think of Kotlin as shit tribe. If you start working with Kotlin, which I hope you do after this session, you'll see a lot of namespaces in there under the name Jet. And Jet was the code name for the language before we decided to call it Kotlin. Whether that's going to remain Kotlin, I don't know. So some of those namespaces will not be renamed until we ultimately decide on a final name for it. Question that pops up, why Kotlin? Because we had absolutely nothing better to do. No, that's a joke. We have been developing IDEs and tools for the past decade, and all of the IDEs and tools that we've been developing are still in Java, despite making tools for a multiple array of languages. And they've not found, some of the teams, a better fit currently to create tools other than Java. I'm talking about the Java side of the company. On the .NET side of the company, we use C#. So this is kind of the purpose of this language is to kind of be a multi-purpose industrial language that is fit to use and has a series of design goals. One of them being that it has to have full Java interop, because otherwise nobody or their mother is going to use it. No one's going to really start writing things up from scratch for everything they want to do. Eventually, hopefully we will, but not currently. It has to be at least as fast as Java. It has to be safer than Java. And it has to be more concise than Java, which is really not a hard thing to accomplish in life. And it has to be simpler than Scala. I was talking to one of the Scala developers, the presenters yesterday, and I said, you know, we could think of a slogan for Kotlin could be Scala for Dummies. But, nah. I don't fit. How many of you like Scala? Right. A word of warning. Don't compare this to Scala. Right? In fact, on our Confluence page, one of the disclaimers is if you're happy with Scala, you do not need Kotlin. Right? So let me ask that question again. How many of you know Scala, like Scala? Okay, you're free to leave now. No, I'm joking. You can stay, but be quiet. And don't moan. And don't say, well, in Scala we do it like this. I don't care. Okay? So don't compare me to Scala. And I always say Scala is a very, very, very powerful language for the 4 people that use it. You guys prove me wrong. There's 8 apparently. So Kotlin is a language, and it's a bunch of libraries, and it compiles down to the JVM, and it also compiles down to JavaScript. Our main, right now, we're focusing on getting the JVM part complete. So if you start to work with this, with JavaScript, you'll find that it's lacking in certain areas. It has a bunch of libraries or packages already. You can see some of them here. Nothing that I show you is final. Things will start to become final when we hit beta. Having said that, building real-world applications in Kotlin. How many of you read this abstract to this presentation as opposed to just the title? Okay, that's good. You see, now I don't have to justify the abstract. So the abstract was we're going to build a real-world application in Kotlin to see if it really delivers on the promise. Right? What is a real-world application? How many of you build real-world applications? Fascinating. Pretty much everyone, yet no one answers what a real-world application is. It's too many things. It could be anything. It depends on your line of work. It depends on what industry you're in. A real-world applications is many things. Can we build real-world applications in assembly? Yes, you have to be very sick to do so, but you can. Can you build it in Java? Obviously, otherwise we wouldn't be here. Can you build it in Visual Basic? Yes, but you wouldn't want to. Can you build it in, all of these languages? Yes, you can. The difference is how much focus you pay to the language versus the problem that you're trying to solve. So how much emphasis is placed on ceremony around the language or around the obstacles that the language provides you or the environment gives you versus what you're trying to really build, what you're trying to focus on. So what I want to do in this talk is, and my laptop is actually sliding down. I have a little thingy here normally that stops it, not this place. What I want to do is focus on things that are problematic, in quotes, in a language when we're building real-world applications, and see how we're trying to solve those issues in Kotlin. Because ultimately, yes, you can build real-world applications in Kotlin. Should you do it today? It depends how much you want to risk your life. In the sense that, not really your life, but we are not going to be final until we hit beta. So the official stance from JetBrains is do not build anything until do not put a system into production until we reach beta, because maybe we'll change quite a few things. Our goal at JetBrains is to build this and to start converting our tools over to use Kotlin. That is our goal. We've started doing that. Now we have a library called K-annotations, which is annotations library used in Kotlin. That's entirely built on Kotlin. Next step is going to be the rewriting of the compiler in Kotlin, and so on and so forth. Okay, so we are, we're full board on with Kotlin. So I'm going to dive in, and I'm going to show you some stuff, and then we'll come back and see what other people are doing with Kotlin today. How many of you use IntelliJ? How many of you use Eclipse? Right, keep your hands up. That's punishment for using Eclipse. No. How many of you would like to use IntelliJ? Really? I saw a board out there that said, what IDE do you use? What IDE would you like to use? And IntelliJ was quite like the winner. I think there was one guy that said V. But anyway. So I'm going to use IntelliJ for this. Obviously, if you use Eclipse, there is actually a plugin that's being developed for Eclipse. And the IntelliJ version that you can use for Kotlin is open source, is the community edition. Did you know we have an open source edition of IntelliJ? Right, good. So it's completely open source. It's on GitHub. You can download it, compile it, or just download the binary from our site. And Kotlin you can use inside there, all completely free. If you don't like IDEs, you can also use the command line compiler, although there is no step-by-step tutorials just yet. So I'm going to create a new project here. And what I will do is create a file. Can you see this nicely up there? Yeah, all good? I'm using the Darkula theme, so I'll create a Kotlin file. First thing you do, when you set it up, it says, do you want to target the JVM or do you want to target JavaScript? So I'm going to say I want to target the JVM. Hit OK. And now I can do package something. Now, and then I can use templates to create a main function, which is the entry point for Kotlin, and say, hello, world. Right?
This is already fun.
This is already fun, yes. Because of the fun. You get it? That's how we declare functions. It's fun. No? No? The joke's not working? No? Okay, never mind. So I actually don't do any more hello world applications. I do how you doing kind of applications. Okay? It's kind of become my personal motto. How are you doing? You right click and you hit run something. And it all works. So how are you doing? And it all works. And it all works. Oh, and it works. Great. So you have breakpoints. So I can set breakpoints. Obviously, that's not going to be of any value. If you're not familiar, how many of you are already familiar with all this type of code in Kotlin? Okay, good. So in Kotlin, we actually have variables as well. And I can create a variable that's called ABC, DEF. And I can do string interpolation. So I could do, for example, ABC, right? And I can run this again. See, second time it should be faster. There you go. And I can set breakpoints, and I can debug. And you can see that I have, I can step over, and I have variable watches, everything. Okay, so you have the full built-in IDE. You already today even have refactoring, right? So I can click here and refactor this to something, let's name it something that's meaningful like X. Okay? That's about it in terms of refactoring. You do have some additional refactorings, but things like extract method or stuff like that that is available in IntelliJ for Java is not there yet, but we're working on that. But you do have a debugger and you have full IDE support. We also have another thing in Kotlin which is called val, which is why I don't really name my variables like this. I give them meaningful names, like C1. And what this is basically immutable, so I can't do y equals def anymore. Okay? So you have mutable and immutable variables in Kotlin. And that's it. That is Kotlin. Notice something else, that in Kotlin we don't have the concept of, in Kotlin we have the concept of a top-level function. So you can just declare functions, kind of like JavaScript. Okay? And you don't have to have a static class with a static method if you just want to create a function. And that in real-world applications is kind of problematic, isn't it? Because on a team, how many times are you encountered with someone creating a class called something helper, and then your colleague creating another one called something util? Yeah? You've encountered that? Looking to where to place your functions? Because you don't know where to place them, so you just create these things called helper classes. And then they just become like a dumpster of everything. Here, you don't need to create any more static dumpster classes. You can just create dumpster files. I don't mean. Okay? No, but it does open up some doors for us. Another thing, if you've noticed, there is no semicolons required in Kotlin. which is fantastic unless you're a JavaScript developer and you have internal debates with yourself of whether you should terminate each line with a semicolon or not, right? But if you do want to, you can actually put semicolons. It's okay, we allow it. Right. So that is my how you doing demo. Let me close this and go back to my something beautiful. I just said something beautiful and showed some Java code. How is that possible? I come from a .NET background, so don't bash me a lot. Anyway, what is that? Can someone tell me? What is it?
Data class. It's a bean.
A bean? Data class bean? What does it do? Nothing. It's absolutely useless, isn't it? Right? How many of those have you written? Dozens. So, why? Now, if you use an IDE, like IntelliJ or Eclipse, you can just do a little template. Bean, bam, done. But why? Why are you generating all this code for nothing? Why are you writing it for nothing? In Kotlin, you can write it like that. Okay? This over here is a constructor. In Kotlin, we have constructors and they're declared at the level where the class is declared. There are no secondary constructors. Initially, there was going to be, now there isn't. What this means is that if you want two constructors, what do? You use another language. No. What you do is, come on people, wake up. What you do is pass in, pardon? Not static factory methods, optional parameters. If you want a second constructor. You pass in optional parameters. So constructors allow optional parameters because functions allow optional parameters as well as named parameters. There's no such things as fields in Kotlin. Everything is a property. You can access the backing field if you're familiar with C#. Anyone from C# background? In C# we have this thing called auto properties, which basically have an automatic backing field. You can access that prefixing the name of the property with a $sign. But otherwise, there are no such things as fields. You can have immutable properties. You can have mutable properties. You can have private, internal, protected, all those. This is the actual constructor code. So what I'm doing here is I'm saying set the name to the parameter passed in, set the email to the parameter passed in. And then I can do print line, right? Now that is also a little bit too much code for what we're trying to do, right? Again, it's a lot of ceremony when we're trying to focus on the actual application that we're trying to write. So the other option to do with Kotlin is like this. I can just pass in, I can just prefix the parameters with a var or a val if I want immutable, and that's it. So that line of code is exactly the same as the Java bean that I just showed you. If you're using default getters and setters. If you want to override the default getters and setters, you can do so. But normally, for the type of classes that you're creating with Java beans, you don't need to do it like that. Okay? So it's very short, it's very concise. Now, we can actually go one step further. Let me show you data classes. Okay? How many of you know what a tuple is? Right. Initially in Kotlin we had tuples. Then we thought, I'm so sorry, my laptop really, it's going to end up on the floor. We had tuples. And then we had this other thing called, we decided that we're going to do away with tuples. And then we had pairs and tribes. Then we decided we're going to do away with pairs and tribes. Now we don't have tuples anymore. What we have are data classes. A data class is basically just what? Can someone tell me? A what? It's like a DTO, right? A data transfer object. What is a class? Inherently, a class should be an object that has data plus what? behavior, right? Unfortunately, we see so many classes out there that the only thing they have is data, not behavior, and we call it a class. Well, for that, in Kotlin, what you can do is create a data class. If all you want is data, it won't have any behavior. In fact, it would be great if we actually dropped the word class and just called it data, right? So what I'm doing here is I'm creating a DTO that has a name and an email. Now, inherently, out of the box, a DTO, a data class, ships with 3 methods. One of them is toString, the other one is hashcode, and the other one is equals. So out of the box, if I do customer name, I have toString, and you can see that I have 2 customers here, Joe Smith, and if I do an equal sign, compare them, they'll tell me whether these 2 customers are the same. Okay, so you see that the customers are the same. If I go and change this and rerun again, it should say that the customers are no longer the same, so it won't print out the customers are the same. Okay? What happens if I want to override this behavior? Well, right now, you cannot, but at some point, I actually think maybe we will add that functionality, but worst case scenario, you would then need to create your own class. Okay? So this is the answer to solving some of the problems that the DTOs create, which is having loads of code that do absolutely nothing. We have traits. What are traits? We don't have interfaces, we have traits. Traits are interfaces with the possibility of optionally declaring method bodies. So you can have a trait with some functionality and then implement that trait, and if there is an abstract method, then you don't need to implement it in the descending classes. Okay? So here I have an example of a trait, and I'm implementing it in memory, message bus, and I just override those 2. I don't need to override the optional, the function that has a body in the trait. Traits cannot hold state, which means although you can implement multiple traits, you cannot hold state. So you can have abstract properties, but you cannot have instance properties. Another problem we try and solve is enums. This is how you declare an enum in Kotlin. Sometimes what you want to do is the ability to be able to, like, I have a customer invoice type which is issued, pending, opened, etc. And what I want to do is now be able to print out the status in a nicely formatted way. In an enumerator, I can't. I now have to use a helper function and pass in the enumerator, and based on the helper function, do that. What we allow you to do is actually declare methods in enumerators and enum classes and override them. Again, this solves one of the pain points that we have with developing applications. Okay. Are you still awake? Yeah? Are you liking what you see? Just one, okay, that's encouraging. I'm trying so hard not to cough and I get one, How many of you know what dependency injection is? How many of you use Spring? So, here is a typical scenario of dependency injection. I have a trait with a getAll, and I have a customer repository trait, I have a customer repository which implements that trait and implements the getAll functionality. Now I have an everyday controller that passes in as a dependency the customer repository. And what I do is I just create a property of customer repo, and then every time I need to access that dependency, I just use it and do the method call. In Kotlin, we have this concept called delegation, which what it does is pretty much similar to what we have with dependency injection. The difference is that you don't actually have to have a field or property holding the dependency. What you do is you say that the customer repository that you're passing in is delegated by this property, this argument that you're passing in. And notice the difference is that I no longer have to call customer repository .getAll. I just call getAll. Right? So now it's as if that function that I'm calling from my dependency is part of the class itself. How many of you like this? How many of you don't like it? Good. I'm glad. Someone that doesn't like it. Why don't you like it?
I prefer to be more explicit. Customers import original where get all comes from.
Okay. She says that she prefers it to be more explicit.
I think it's too verbose because you still have the customer repository 2 times in there and also customer repository trait.
Yes, I agree with you on that one. I think we could make it more concise. Yes. But not having to explicitly prefix it, do you agree with that?
That's fine.
That's fine. Who agrees with her in terms of I need it to be more explicit? You do. Why?
Well, I didn't have much time to think about it.
Okay, that's fair enough. So, can you make it explicit? I don't think so. No.
It reminds me a bit of Delphi with default properties, which I don't like, or basically.
Delphi was a beautiful language.
Yeah,
Yeah, I did a lot of Delphi.
yeah.
Would it be possible to what? Okay, so wait, I think what I'm going to say might resolve your problem. The basic issue here is that I have now getAll and I'm not explicitly saying where it comes from. What happens if, in this case it's fine because I have get customer repository that might have 3 methods and I'm going to call these methods. What happens if now I have 4 dependencies that are being passed in? Now it starts to become a mess because I don't know where each dependency is coming from. But that is actually a code smell. Because if you have a class, what is the main purpose behind dependency injection? It's to decouple classes, right? It's to not depend on a specific implementation, but it's to decouple classes. If I have one class that is taking in 4 dependencies, there's too much dependency between that class and other classes. Too many dependencies in a class is normally a sign that that class is doing too much, that there's a level of abstraction that is missing. So while you could not use delegation and just explicitly define your dependencies and then use those dependencies, what you're actually doing here, if you start to run to too many delegated responsibilities and you don't know what belongs to what, you normally have a different issue, which is that class is doing too much. Dependency injection doesn't solve single responsibility. It doesn't. It just passes it in as a parameter. So there is that issue. So in terms of name conflict, which you were asking about, it's hopefully you wouldn't have that problem. So initially it seems kind of like, nah, I don't know, but if you really think about it, I think that the underlying problem is different. We don't have tuples, but with data classes you can have multi-declarations, which, for example, this is very good when we're doing coding, because we're more explicit in our intent, right? Just the same way that we define functions nicely with good names. How many of you name your functions nicely? How many of you have an and or an or in your function name? Right. Bad. Okay? How many lines is a normal function? How many lines should a normal function be? 20, 30, 40? Less. 10? 1, 2, 3. Right? If you have, a function, much like a class, should only do one thing. And if you have an and or in it, it's kind of doing 2 things. You separate that out into 2 functions. And being explicit about the name, that's the core thing when you're developing applications. Naming is fundamental. right? It is one of the most important things. And when we're doing iterations, I want to know what I'm iterating over. So I can use multi-declarations to do like, this is the key, this is the value. I can also use multi-declaration when I get coordinates out. I can say x and y and refer to x and y. So in this case, get coordinates, what it's actually doing is returning coordinates, and then I can use multi-declarations to refer to those. Okay? Or explicitly just create an instance of the data class that it's returning. Again, this is solving specific issues that we have in real-world applications. What else? Now here's where it gets interesting. How many of you know what lambda expressions are? They're coming in Java 8. We already have them. First of all, we have a bunch of things. At the top, I have inline function. So a function that just does something very simple, which is the majority of the functions, can be declared inline. You don't have to open the braces, close the braces. You don't have to explicitly define the return type. It will infer it. Then I have infix calls. But before explaining infix calls, I'll tell you what this is. In C#, if you come from a C# background, you might be familiar with the concept of extension methods, which basically means that I can take a class and add functionality to it. I can hack it, in a way, without having to inherit from that class. Which reminds me, inheritance. In Kotlin, by default, everything is final. So if you want to inherit from a class, you have to prefix it with the key name open. Why? Because you have to design your class for inheritance. Plus, we all know inheritance is bad, right? Composition over inheritance, done. Okay? So what we can do in Kotlin, in C#, to create an extension method, you have to create a static class, then you have to create a static method, and you have to pass in a parameter to that static method, which is this, and then the type, and then the name. In Kotlin, you just add a dot and the function you want to add to that class. So what I'm doing here is I'm adding a function to the int class, which is add2, and I'm declaring it inline. When I do that, I can now also, any function that has one parameter, two parameters, can be called in infix notation. So I can do value of sum is 2 add 2, 5, which allows for a little bit of a DSL approach, which we'll see a little bit later on. Function literals, or lambda expressions, we've had them for a while in C#. I think they're coming in Java 8. Kotlin already has them. So here I'm saying that this is a function that takes two parameters of type int, which allows me to do x plus y. This is another way to declare it, x int, y int, x plus y. Basically, I'm inferring the return type. This is another way of declaring it, int returns an int. So I'm declaring the type of the function and then the expression of the function. Okay, so x, y equals x plus y. Because that's how you can declare variables. In Kotlin, a variable, you can just do var, name of the variable equals, initialize it with a value, the type is inferred, or you can do var, the name, colon, the type, and then optionally equals and the value. What I'm doing here is creating an expression function over here, this one here. Don't look down, look at this one. Okay, here, concentrate on this, please. I see some people going, what's that? What I'm doing there is creating, much like the add2 to the int, I'm creating a space replace. So basically what I'm saying is that the string, the actual object that I'm operating on, replace a space with a character. This refers to the actual instance of the object. Now the next step to this is extension function literals, which basically means that I don't have to explicitly declare an extension function. I can just declare it as a function literal. So what I'm doing here is creating an extension function to string that takes no parameters and replaces all spaces with underscores. This is all going to add up, and I'll show you what you can do with these things. So, and high order functions, which basically means that I can have a function that takes a function as a parameter. This little thing over here, I'll get to that later on. So I can run this and all works beautifully. How you doing? And 5. Okay? I've not had the demo fail on me just yet. That's amazing considering I've done these demos like 15 times. Okay. Singletons. Do you like singletons? It's serious. This is a really easy question. It's just yes or no. Do you like singletons? No. Nor do I. But sometimes they're a necessary evil. In Kotlin, you don't have to create a singleton pattern because we have objects. You know how in JavaScript you have objects and not classes? Right? There's no such thing as a class in JavaScript. They're in ECMAScript 6, I think they're going to introduce. Microsoft decided to create TypeScript, and now they have classes. But there's no such thing as a class. You kind of simulate it. You have objects. Well, in Kotlin, we have classes and we have objects, which means that if I want a singleton, all I do is just say this is an object. Anonymous object, var, counter, non-anonymous object, sorry, singleton, and it's got a counter to 0. And then I could just use that. Okay? And I can also have objects that implement traits or inherit from abstract classes or from open classes. So here I have an object which extends extender, which means that it's going to have the increment method on it. This comes in useful in a demo that I'm going to show you later on. Null safety. There are no nullable types in Kotlin. So you really won't get a null reference exception unless you're, or a null pointer exception unless you're really looking to try and get one. I can declare a string, give it a value. If I do string null, it's going to say, nope, it's not going to happen. I can create nullable types though. So if I say that this string and put the question mark, it means that it can be a nullable type. What happens if I do print string length? Well, on the string, it's fine. On this one, it's going to give me an error saying that it might be null. If I add that, it's going to say do it if it's not null. If it's null, don't do anything. Why do I need this operator, the safe operator? Well, because when I'm working with Java, right, it comes in useful because Java returns null types. So here I create a file and I say if files is not null, print line, or I can just say print files size if it's not null. Since it returns an int, but Kotlin treats it as a nullable int, it won't do anything. I also have the Elvis operator, which means if it's null, if it's not null, print the size. If it's null, then write empty files. And this guy over here, because if I don't put this, it's going to say that this is null. And I want to say, no, I don't care it's null. I love this crap. So I'll put double exclamation mark saying, I know what I'm doing. This is pretty much the only way you can get a null pointer exception in Kotlin. If you explicitly say that you know that this is null, but I'll still try and call it. Okay? Why is it 2 exclamation marks? To be really, really ugly and obvious. That gets rid of a major pain point that you have in developing applications with a lot of languages. Casting. I have a trait that implements a device, that's a device, and then I have a class that implements it called printer that has a function called print. I have an OCR that implements it that has a function called read. I can do this. Notice what I'm doing there? I'm not casting. The compiler realizes and says, okay, you're saying if it is a printer, then call print. You don't need to explicitly tell me again that it's a printer. I know it's a printer because it's in the flow, it's saying it's a printer. By the way, we don't have any you don't have to explicitly declare your exceptions in Kotlin either. Have you done this code? Casting? Ever? Do you like doing it? No? If you do, stick with Java. Here's another one. This is a case statement or a switch statement. And notice all of the different patterns that I can use. So 0, 1, 2, 3, a enumeration of numbers, in a series of values, not in a series of values, the result of a function call, or an else. And I can even have variables in here. So I can have x equals print line var, and then have rx equals 10. Okay?
Why do you need the in keyword? Because the enumeration looks like the range.
Probably something to do with the parsing. I don't know. Follow up with me later and I'll get the devs to respond to you. There's some things that you need to do for parsing. Okay. So what I want to show you now is some things that having all these functionalities, what we can build up. By the way, look at this. This is actually, let me go back to my other, okay, I don't have the other project. This is, if I do val x equals 2 plus 10, print line x, what do you think is going to happen if I run that? What do you think is going to happen if I run that? Tell me. It's there. It's going to print 12. Why is it going to print 12? Where's plus? What is plus? It's a function. But it's also, we use some conventions. Plus is the actual plus operator. So you can override operators by using our conventions. A plus will override the plus operator. A plus append, a plus assign will override the plus equals operator. Okay? There's a whole bunch of conventions that you can use. So, let me show you something here. This is a function that takes another function as a parameter, which takes an integer and returns an integer. And here I'm doing single, but notice what's missing there? The parentheses or the brackets. So I'm not doing that. I don't need to do that. If the last parameter to a function is a function, I can omit the parentheses. Okay? This allows me to do weird stuff like this. There's also a control A which does this, but I just like to take my time and do it. So here is, are you familiar with Groovy? And the Groovy builders? HTML Groovy builders? So Groovy is a dynamic language and you can create HTML fluent builders like that. This is the same thing in Kotlin. The difference is that this is statically typed, statically checked, compile time checking, navigation, the whole works. And this is a combination of lambda expressions, infix notation, conventions so that you don't have to use brackets when you're calling functions as the last parameters, lambda expressions, etc. So I can click on each of these and navigate to the actual function. This enables me to create DSL-like languages, which enables me to be more expressive about the business application that I'm trying to solve. Here's another smaller example of using swing. Okay, this is creating a swing component using code. This now looks like Delphi, DFMs. If you remember Delphi, you would do a text as DFM, and it would look something like this. Okay? So, let me show you now something else. If there's one thing missing to create an application, a real-world application, the one minimum thing that you would need in order to do that, what would it be? Can someone tell me?
Libraries.
Good. Libraries. What else? Tests. Good. Unit testing framework, right? Now, the beauty of this is that Kotlin is fully interoperable with Java. So I can call Kotlin code from Java and I can call Java code from Kotlin, right? What this means is that I can use anything that's in Java today. For instance, here's an example of something that I've been working on. You can use JUnit to write your tests in Kotlin. You can also use this library, which I'm working on, which isn't finished. But how many of you went to that BDD talk earlier? So I don't want to classify my libraries with a BDD TDD because I'm against that philosophy. But this is a library that I call spec, which we're in Belgium, and spec, you know, means bacon. So this is BDD as in bacon-driven development. And what this is basically specification. I consider things to be specifications, not unit tests. So this is a specification. Given a calculator, and I create the context, on calling sum with two numbers, and I call the action, it should return the result of adding the first two numbers to the second, first number to the second, and I do the assertion. If I share a context, which in JUnit would be inheriting from a base class, I just add another action and another it. I can have multiple its here if I want. Normally the convention is to use one assertion per it, so you exactly know where it goes wrong, because the last thing you want to do is what? Be debugging unit tests. Then you defeat the purpose of unit tests. Here's a sample. I just run this. This code is available on GitHub, and you can see that it's creating for me. This is a sample runner, and then there's going to be an HTML runner and an IntelliJ runner, but this is the output. Okay? We have quite a few of these frameworks in .NET. One of them is called mspec, so this is partially inspired by mspec. So it's very much about writing your business specifications and having those directly translated into code, which is what it's all about, what unit testing is all about. Once you write those, then your unit tests become regression tests. Okay? So that's available also. It needs work, but it's getting there. And what I'm doing here, the other reason I wanted to show you this, apart from brushing my own ego, is to show you how we don't have reflection in Kotlin just yet, but I have reflection in Java. So this is a Java class. Okay? And this is going to load up the classes, and it's going to get back all the types, specifications. What are specifications? Well, here's the thing. I'm actually declaring the annotation spec in Kotlin, right? And I'm using it from Java over here, spec.spec.class. So I'm using Java from Kotlin, and then I'm using Kotlin from Java, and then in my specification runner, in my specification, what I'm doing is creating an instance of my Java class and calling the methods on it. So absolutely and completely interoperable. Yes?
Can you compile Java classes and Java files and Kotlin classes in one go then?
Yeah. This is part of the same project.
Okay.
The only thing you cannot do currently is Kotlin allows you to target the JVM and the JavaScript. You cannot target both of them in the same project. Okay? So this code, all of the code that I'm showing is going to be up on GitHub. Well, this spec is already up on GitHub. The demos from this session are not. You can ping me and I will send them. Are not. You can ping me and I will send them to you. Now that's a little bit about the problems that we're trying to solve with Kotlin, and hopefully they kind of give you an idea of if they solve real-world applications. What else is out there? Vertex, if you've seen Vertex, there's already a Vertex port of Kotlin. Someone is working on porting Vertex to Kotlin so that you can use it using Kotlin as a language. There's Cool.io, which is a web-based framework for developing web applications in Kotlin. The author of this primary author is James Strachan, who's the guy behind Groovy as well. He's also a big contributor to Kotlin itself. This is a project that I picked up, which is a wrapper library for Kotlin for Android. And I was talking to the developer of this, and I said, you know, I want to know your experience of Kotlin. What is the one thing that you feel that Kotlin provides you, that you're not using Java? And he said, I'm writing much, much, much less code. And the code that I write is much clearer. Okay? Spec is the one that I just showed you. Other possibilities right now, if you go to the Kotlin website, which is kotlin.jetbrains.com, you do have a Web IDE running, and inside the beautiful front page. Too bad the rest of it isn't like that. And this is, you can play with Kotlin here, and you can also see some of the the JavaScript output. So for example, I can do creatures, and this is Kotlin, but targeting the JVM. Okay, but it's all still Kotlin code. And if I run this, it should all work nicely. Yeah, so I can do things there. Okay, so that's also available, and we also are providing scripting, so you can do Kotlin scripts. Real world apps then. Idea is to concentrate on the value and not have to deal with the ceremony and the restrictions that a language imposes on you. And also, it should enable you, not restrict you. And hopefully, with the features you've seen in Kotlin, we're trying to reach that goal. We're giving you the ability to use anything that's out there in terms of Java interop, and we're also trying to make it very concise so that your code represents more the type of application, what you're actually writing, as opposed to dealing with ceremony of code itself. Tooling, of course, is another factor, and in our case, well, we have that advantage that we're always going to be providing tooling. And we will probably, there is already someone working on Eclipse. If they don't, we will probably provide ourselves an Eclipse plugin. Okay, so we're not, the idea behind this isn't, oh, we're going to lock you into IntelliJ, because in fact, IntelliJ Open Source Edition will always support Kotlin, and you'll always be able to use it with that. Okay? So to play with Kotlin, you can download it from, just go to kotlin.jetbrains.com. You have all of the information available there, documentation, source, links to GitHub, etc. Everything is there. All of these links are available there. And on Twitter, there's also Project Kotlin. So if you have any questions or anything, you can ask on Twitter or my own data. My information is hadihariri.com. I've got a series of blog posts also on Kotlin there, and my Twitter is hhariri, and that's my email. And we have about 2 minutes left, so if there's any questions, yes?
You mentioned you also have a .NET part of the company. Why doesn't Kotlin target .NET?
The question is, we also have a .NET part of the company. Why doesn't Kotlin target .NET? Currently, it does not. And I can't say to you right now if it will, but we are starting to get a lot of demand, well, not a lot, but quite a bit of demand of, hey, this would be great if it would run on the CLR. Okay, so it's something that we are thinking about, but nothing firm yet. So, you know, don't take my words out of context. Or you can and just say whatever. Any other questions? Yes?
Can you tell us quickly something about modules and versions? Is there support for modules or reasoning about your code?
Currently, the support for modules is still being worked on. Right now, you have the packages, and everything basically is in packages, but the module part isn't final yet. So,
and versions?
I'm not sure yet. That's still in the works as well. But if you send me an email, I can put you in touch with Andre, who can answer that. Yeah?
What are traits actually in Java? And interfaces? Or?
Well, traits, the most equivalent thing in Java would be an interface.
Yeah, but you said they are interoperable systems. So how Java sees traits?
Right now, Java would not see traits. It would not see traits. No. Right now, I think there is that limitation. Because in fact, I was trying to use one of the mocking frameworks, and I think I was running into issues. Well, I was running into issues with that, but I'm not sure if it's something that I was missing or not.
Is the dispatch logic different than default interfaces in Java 8?
I'm not sure. I would have to check with that. If you send me an email, I can try and get one of the team guys to let you know.
You are familiar with Java?
I'm not a Java language freak, and I don't mean freak in a bad way. I mean, I'm not a Java guy in a sense, right? So, my experience or world where I picked up the JVM and that is with Kotlin. Okay, so I'm not deep into Java to be able to.
Explain that the interoperability is the main goal of Kotlin.
Yeah, but I'm not saying that it's not going to be compatible. I'm just saying that currently I've found limitations. But if you send me an email or give me your card later on, I will find out from the team and let you know. Okay? Yes?
How do you compare Kotlin to Ceylon?
How do I compare Kotlin to Ceylon? Well, it's quite similar in both languages. But it's I don't know. I mean, I can't really. I haven't worked with Ceylon that much to be able to say how I compare it. But it's the same as Scala. Well, I guess Ceylon is more comprehensible than Scala. But I don't know. That's for you to decide, not really me. So time's up. If there is any other... Okay. Yeah.
What about timing? When will we expect final release?
We're hoping sometime probably mid next year. We've just released M3. M4 will probably ship sometime in the first semester, I'm hoping. But I'm aiming at mid next year. We're aiming at mid next year that it will be released. Okay. So time is up. This red and white thing is flashing on me. It's been a long week as well. Thank you very much for staying out until the end. If you do have any questions, just email me and I'll try and help. Okay. Thank you.